4.6 RSG. This is going to be really bad. I'm going to start this video by telling you what you are not going to do. I am really not worried about you guys doing the ready right now. This is stuff that we're moving into in chapter 5. So we will see this next semester. It is really going to be pointless for you to do it now, for us to not see this for 5 weeks. We have our 3-week break coming up, and we still have 2.5 weeks left in this semester. So we're looking at quite a while, and I'm going to have to re-go over it with you then. So unless you want to practice, I am going to say do not worry about the ready. So let's look at the set. Provide the features of the function. Be sure to include a sketch of the function as well as domain, range, increasing, decreasing, intercepts, max, min, and behavior asymptotes, blah, 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 blah. Okay. All of this is on your foldable. Everything is there that you need. And if it's not there yet, maybe look at your polynomial foldable. We've talked about end behavior in the polynomials. We've been talking about max and min since Math 1. We've been talking about all of this stuff, actually. So I really want you to practice this. You don't have a lot here for you to do. You got a whole whopping 6 of them. Good luck with 12. Have fun with that one. You are going to use these features to create a rough sketch. So you want it as accurate as possible, but I'm not going to have you test a whole bunch of points. You have a list of steps to follow as you are identifying all of the features of this function. I am going to go ahead and, since we are really not going over the oblique asymptotes, number 8 does have an oblique asymptote. I would like you guys to find everything else for this function. By the way, I know it has an oblique asymptote because my top degree is 2 and my bottom degree is 1. So the top is bigger by 1, and that's case 3. Case 3 has an oblique asymptote, and you have to use long division. So if we talk about that in class, that's fine. But I would like you to find everything else. You just do not need to graph it or find the end behavior or the max and the min. Don't worry about that. Okay, that's not a big deal. But for this one, you guys can find the x-intercepts, the y-intercepts. You can find the vertical asymptote. If you want to practice, go ahead and find the oblique asymptote. And you can also find the domain from that. So find those. But for everything else, I want you finding the vertical asymptotes, horizontal asymptote, if there is one, the intercepts, domain, and then from that, I want a quick graph after you've tested some points, and then from there, you guys can find your range and where the function is increasing or decreasing and the end behavior. So I think I am going to go ahead and do I'm going to say do not do number 12, you guys. Well, don't graph it. Let's do that. Do not graph this one. But you guys can find the x-intercepts, the y-intercepts, the vertical asymptotes, the horizontal asymptote, if there is one. You can find domain. Find that. In 13, I want you to do all of this stuff plus the graph and the range. In 11, you have another oblique asymptote, so this one you don't need to graph either. Don't worry about that, but you can do an analysis on it. I think I am going to do with you guys number 10. I think that's a good one to do with you. So I don't need to factor. Not factorable. Can't cancel anything. So I'm going to start with my vertical asymptotes. Don't forget your vertical asymptote comes from the denominator. So x minus 1 equals 0, so x equals 1. I'm going to find my horizontal asymptote. My top degree is 1. My bottom degree is 1. Since the two degrees equal, I use my leading coefficients. So there's my leading coefficients. It's x over x, and x divided by x is just 1. Now I'm going to find my x-intercepts. My x-intercepts comes from the numerator. So x minus 2 equals 0, so x equals 2. So 2, 0. And then I'm going to find my y-intercept, which comes from making all of your x's 0. So 0 minus 2, 0 minus 1. So y equals 2. So 0, 2. Okay, now my domain. We need to remember your domain comes from your vertical asymptote. So my domain is x such that x cannot equal 1. That's an asymptote. That's our vertical asymptote. That is the only number x cannot equal. So I have all of this. Now I'm ready to create a graph. All right, pretend number 11 is not there. Okay. Well, let me put in some lines here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So to graph this, I'm going to start by drawing in my vertical asymptotes. So at 1, I put a dashed line. Now my horizontal asymptote, at 1, I have a dashed line. My x-intercept is positive 2. My y-intercept is positive 2. Well, that's nice. So I don't have to test points on this one because I have a point on the left and I have a point on the right of my vertical asymptote. So I can just draw the graph. If I didn't have a point, I would have to test a point on the left and plug it in, see what I get, and that's the point that I would plot. Then I would pick a value for x on the right, plug it in, and then get my y value. Then that would tell me the behavior of my graph. Now, for the end behavior, as x approaches negative infinity. So what arrow is going to negative infinity? And you got 4 arrows here. I am okay if you just stick with the negative infinity. As x is going to negative infinity, this guy right here, f of x is approaching 1 because that is your asymptote. It will never cross 1. This arrow, if you wanted to, so that's this one. This one is as x is approaching, what is the vertical asymptote? 1. F of x is approaching, well, the arrow goes up, so infinity. This arrow, that's x going to infinity. And f of x is approaching the asymptote, so 1. And this arrow, as x is approaching another asymptote, 1. F of x, since that arrow goes down, it's approaching negative infinity. So you have a lot of different end behaviors there. The two that matter the most are as x approaches negative infinity and x approaches infinity. Those are the two main end behaviors that you do need to make sure you're writing. So it's not hard work, you guys. It is something that takes practice. Take your time. When you are not getting something, make a note so you can ask me for help. Come in and see me in the morning lunch after school or get my attention in class and I will help you. Practice these, you guys. You don't need to graph 8, but you need to analyze it. You do need to graph 9 with the analysis. Oh, I forgot the range. 12, no graph, but do the analysis. 13, all of it. So the range. The range I can only get after I have graphed this. So the range is the y values. So I start at the bottom, it goes up, 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 up. Uh-oh, there's a horizontal asymptote. So it's y such that y cannot equal. What is our horizontal asymptote? 1. So the range usually will come from your horizontal asymptote. Not always, but usually it will come from your horizontal asymptote. All right, that takes care of the set, I believe. Now the go. We have been struggling with this. We are struggling with this because we're not factoring. Every single one of these questions here requires you to factor. These 3 here, you need to factor and cancel. That is a must. In 16, you can factor. Actually, let me do 16 with you to get you started, and then that will help you with 18. And then 19 is division. So once you rewrite it, then it's like 14, 15, and 17 with the multiplication. So don't forget with 19, you must take the reciprocal of your second fraction. And then you guys can cancel. Do not cancel until you take the reciprocal. Now 16, I can factor the top. Well, I can factor all of these. So this is x plus 6. Forgot the plus sign. X plus 6, x plus 2 over x plus 6, x minus 3 plus x minus 8, x plus 5 over x minus 8, x plus minus 3. Oh, this is a nice one for you guys. So when I am looking at canceling, I want to see if I can cancel before I add, because I need a common denominator before I can add. I'm going to look at this fraction. And in this fraction, there's a pair that I could cancel. And then I'm going to look at this fraction. And there's another pair that I can cancel. So this now simplifies to x plus 2 over x minus 3, x plus 5 over x minus 3. Well, that was nice. They already have a common denominator, so now you just need to add the numerator. You get 2x plus 7 over x minus 3. I did the easy one, guys. In 18, you will have to get a common denominator. So make sure you multiply by whatever you would need to make a common denominator if nothing cancels. And don't forget, not everything is factorable. And just because you can factor doesn't mean that something will cancel. So don't force the factoring on these if they are not factorable. Do not force the canceling. Do the best you can, but we should be getting better with these. Practice, practice, practice. Perfect practice. So that way you can be ready for your quizzes and your tests. Questions? Ask me tomorrow.